Alright guys, let's get started. I'm sorry, I did the whole video without you. Realized my mic was not on. Actually, it wasn't a mic at all, it was headphones, but it was working. But we'll get started. This is going to be our for loop and our while loop video, and I am going to try to go as fast as I can while giving you all the information you need. So for a for loop, we have for loop, some matrix, some statements here, and end. These statements are everything that you've learned up till now in MATLAB. We could have an if statement in there. We can have some built-in function in there. We can have some matrix manipulation in there. We can do, and what else did we learn? We could do some plots in there. Everything that you've learned, we can do. And we do that so that we could do it for every single value in the matrix. But sometimes, you know, it gets a little tricky, and that's when I don't even know what I'm trying to say. let me just show you. I'm sorry. So we have statements in here, and this loop is going to iterate for as many columns as there are in this matrix. So let's keep it simple. Let's say I is equal to 1, 2, 3, 4, and 5. And we're going to say display I. And we're going to pause just for a second. And we're going to end. I don't know why I did that. Let's just find how it was. We'll run it. And we'll call this example 1 ex1 underscore 1. I already have an example 1 because I was silly and I did the video without you. But you see here, for every time that the loop is looping, that the for loop is running, it's a looping, I is going to be equal to a different column. So the first time it loops, it's going to be equal to the first column, and so forth, second, third. And it's important to note that it's a column. So if I had multi-row here, and I had some random numbers, if I run this, it's going to show 2 numbers at a time now, because we're just pulling from the first column. So the first time that it loops, it's going to be 1 and 3, and the last time that it loops, it's going to be 5 and 7. Just shown right here. And that is the entirety of a for loop, guys. We have just done a for loop. That was quick. Let's show you what a while loop is. While some condition, some statements here, end. And again, these statements could be an if statement. It could be some built-in function. It could be matrix manipulations. It could be a plot. What else did we learn? I feel like there was something else that we learned. Oh, we could call one of our own functions, and I think I have a function called ln that I created. Could we put a function in here? Oh no, I've never done that. That's question left for another day. Well, let me show you how a while loop loops. So, oh, did I show you this? This is a while loop. This is some statement here. If I take away this while and I change it to an if, this is the same format as an if statement. While loop, if statement, while loop. Ah, that's pretty neat. The condition that I'm talking about here is we use less than equals, equals does not equal, greater than equals. So let's get started. Let's do a while loop. Let's do a while loop that the condition does not change, so that I can show you what an infinite loop looks like. Well, x is less than 5. Display hello world. And when you guys do this, I want you to type something really funny in there. Borderline naughty. Just so that you remember it. I'm not going to do it because, yeah, I'm not going to do it. But let's see how many times this loops. Let's dock it, and let's see how many times hello world is displayed. And I'll call this example 2_2. It's displayed a lot. And to break this infinite loop, you click on the command window and you press Control C. And it stops it. So undock, we'll say x is equal to x plus 1. You guys have to have this in here. X minus 1, x plus 1. If you guys don't have x changing, you will get stuck in an infinite loop. And so here we have x is equal to x plus 1, and as long as x is less than 5, it's going to display hello world. How many times do you believe that this will loop? Well, I know it to be 5. And it counts it for us. That's pretty neat. But let's undock it and count it ourselves. So 1, we're just counting hello world. 1, 2, 3, 4, and 5. It's perfect. And had I have suppressed that value, we would have got x is equal to 1. It's important to note that we could also change this to count. Let's keep x is equal to 0. Then count is equal to count plus 1. And all I want it to do is to display count at the end. What this does is it counts how many loops, how many times it's looped. Display count. 5. Looped 5 times. It's helpful because if x is equal to 106 or 1678, and as long as x is less than some ridiculous number like this, we could figure out how many times it's going to loop just by count. I should have suppressed hello world. I have no idea when this is stopping, but MATLAB's pretty quick. It looped 430,470 times. It's a lot of looping. Well, showed you a for loop, showed you a while loop. Let's jump into it. For those of you who are not in UNM CS 151 class, we are working out of MATLAB for Engineers, Holly Moore 4th edition, brought to you by Pearson. So here we go. Let's undock and let's do problem 9.1. Use a for loop to sum the elements in the following vector. Well, let's write that vector out really quick. 1, 23, 43, 72, 87, 56, 98, and 33. I'll have 4 right here, and y is equal to y plus x. And I'll end it, and let's put an initial condition of y, 0. So the first time that it loops, y is equal to 0 plus 1, and so y is going to be equal to 1. And the second time that it loops, it's going to be 1 plus 23, which means y is going to be equal to 24. And the third time that it loops, it's going to be y is equal to 24 plus 43. That's too much math for me right now. I don't know what that is. So I think what I should do is I should copy this Control C. Let's dock this. That's a CLC clear down here. I'll paste it. We'll find the sum of x right now. It's 413. So I've suppressed everything here. At the very end, I want it to display y. And we're hoping that 413 pops up. That shows that we did it correctly. And we'll call this p underscore 1 underscore 1. That's the second time I'm doing the problem. 413. It does work. That's good. Let's undock it. Let's go to the next problem. Repeat the previous problem using a while loop. No problem. So lucky for me, I could just paste. I have x right here ready to go. Let's see how long x is. We gotta count up all these columns. 1, 2, 3, 4, 5, 6, 7, 8. 8 columns. We'll say I is equal to 0 while I is less than 8. Y is equal to y plus x of I, and we got increment I is equal to I plus 1, and we want to display y. And there's one problem here. There's no such thing as x of 0. So we got to say x of 1. We still want it to loop 8 times. We could express this too. What we say at 413, that's what we're looking for right now. CLC clear. Let me undock this so that I could talk you through what I did. When you're changing over from for loop, it's important just to put your matrix on top. Have an I variable as the one that's being incremented. This is your condition statement. And it's pretty much going to be the same thing as the for loop, except here I have to say x of I, because in a for loop it was just looping and x was being given to us as I anyways, or as x previously. Here we have to call x, the variables in x, whereas in for loop, for that loop it was x. So that's really the only difference, and we have to be incrementing I so that the loop will eventually stop. Did we loop this yet? I don't think we have. And I'll save it as p underscore 2 underscore 2. Oh, what did I do wrong? Oh, I didn't set y equal to 0. Sorry guys, that was my fault. Y is equal to 413. Perfect. That's what I want to see. No, I didn't suppress these. I should have. Let's do it one more time. I is equal to 1, and then 413 is equal to 1. Okie dokie. Let's keep on going. And we'll do problem 3. Let's clear this. Oh, you know what? Let's not. I don't want to clear that. I want to show you guys something at the end, if I remember how to do it. I should probably look it up really quick. I'll do it at the end. Problem 3. Use a for loop to create a vector of squares of the numbers 1 through 5. So square the number 1 through 5. We can say for I is equal to 1 through 5. We're going to create a vector y of I is equal to I squared. And we're going to dock it and CLC. Let's clear it also just in case. And you'll see that it will just be the vector y, which is equal to 1 through 5 squared. What problem is this? 3. And 1, 4, 9, 16, 25. Perfect. Use a while loop to create a vector that squares the numbers 1 through 5. Okay, so let's do it again. This time using a while loop. And I'll undock it. So what we're going to do is we're going to set up our matrix 1 through 5. We're going to set up our condition statement. We're going, I think that's it. While I is less than 5, y is equal to y of I is equal to x of I squared. And display y. And then I gotta come up here and fix everything. And since we don't have a 0 position, we gotta change this to 1, change this to 6. And we also have to have an increment. And then we dock it and we run it. And we'll call this P underscore 4 underscore 4. I have no reason for the label in it. I don't know. But you see it's 1, 4, 9, 16, 25, the same as the for loop. So hopefully I did that right. We could do it by hand if we want, but I think everybody can see that that's 1 through 5 squared. Let's do 9.5 really quick. Oh man, I am killing it on time. I hope I'm not going too fast. No, I don't. I want to show you guys that part. So let's do it. Use primes function to create a list of all of the primes below 100. Now use for loop to multiply the adjacent values together. For example, the 4 prime numbers. Okay. I already did this, but I think it's important that I show you. If you don't know a function, say help primes. You guys can pause it, read it, and it'll tell you what the function does. So I say x is equal to primes. No. Oh, yeah, x is equal to primes of 100. And then now use a for loop. For I is equal to 1. For I is equal to 1 through the length of x. Now use a for loop to multiply the adjacent. Okay, so you see that the first variable in x needs to be 6. Right, so we could say x of I. That's a good place to start. We need this to equal 6, and we get 6 by multiplying the first variable in primes times the second variable in primes. So the first variable of primes, we don't want that to be x, we want that to be some matrix I. Equal to the first variable in x times the second variable in x, I plus 1. This is just for the first loop that I'm referring to, but after it gets going, it's true. And then end. But there is one trick here. You see that we start out with 4 numbers here, we end with 3, and that's because we only have capabilities of having 3 numbers when we have 4 total. So what we need to do, let's say the length is 25. I don't know what the length is. Well, let's just say that it's 25. M of 25 is equal to x of 25, that's how many values are in x, times x of 26. There's no 26 value. So here what we're going to do is subtract by 1. That way the largest number we could have is 24. M of 24 is equal to m of x of 24 times x of 25, and that is correct. And so let's run it, and we'll save this as p underscore 5 underscore 5. I don't know why. We're going to dock it, and we're going to run it. Did it run? Did it do it? No, I suppressed it. Press that and X. Let's press this, both of these, and it ran. Now let's do it one more time, guys. I'm sorry. Let's CLC clear and close all. Why not? And let's put my name at the top. And let's call this problem 9. Undock, and then we can comment here all the prime numbers less than 100, and here subtract 1, and I don't know, whatever comments you want to put, and then we run it, and nothing displays, but we can see that let's undock this. We have an x variable, we have an m variable, and if we did this correctly, the first variable here, 6, should be the same as 2 times 3, which it is. The next variable, 15, should be 3 times 5. 35 is 7 times 5. 7 times 11 should be 77. Let's see if it works towards the end though. 89 times 97 should be 8633. 89 times 97. So we did that correctly. That's good. Let's go back here and let's do one more. I think we have time. Let me see what time it is. Yeah, we could do one more. So I'm gonna pause this and then you guys read it. Well, you pause it, you guys read it, and then come back. Welcome back. So I'm going to start right here. Prompt the user to enter the first 2 numbers of the Fibonacci sequence. So fib is equal to, let me undock that, is equal to input the first 2 numbers, colon 2 spaces, and then we're also going to ask them to input the total number of elements requested in the sequence. So we're just going to say L is equal to input the total number. Now we get to do some good programming. Find the sequence and store it in an array by using a for loop. Okay. For I is equal to 1 through the length of L, and we are going to store it in the sequence Fibonacci sequence. Here you see that the third value is equal to 2, so we'll just concentrate on the first time that loops. So I plus 2, that's the third value, is equal to fib of I plus fib of 2, which is fib of I plus 1. Press that, we can say end. The only problem is that Fibonacci, let's say that the total length is 25 again. Fib of 27 is equal to fib of 25 plus fib of 26. That's not going to work because our total length is going to be 25. So let's subtract 2. And we'll run it. Now it says fib of, well, let's say that L was 25. Now it's fib of I, which is 23, plus 2, which is 25. Now we have 25 numbers in the Fibonacci sequence like we wanted. Here at the bottom we say that I is equal to 1 through the length of L, and we say polar, and here's where we're plotting I comma fib of I, and And I don't know if you guys have seen the Fibonacci sequence plotted in the polar graph before. It's right here. Just spirals. It's pretty cool. Let's dock it, let's run it, and let's call this P_6_6. We'll run it, and the first two numbers will say 1 and 1, and we'll have 25 total numbers. And I messed up somewhere. Index exceeds matrix. Well, what did I do wrong? Fibonacci and L -2. So that's 25. It's going to the loop 23 times. Fib of starts at 3, goes all the way through. Fib of I, I'm gonna pause it. I will get right back to you. Alright guys, that took a little longer than expected. I made a mistake right here. It's not the length of L. L was just 25, and so the length of L was 1, and I went for I is equal to 1 through -1, which was silly. So what I do is this right here. That should work. That's a silly error to have, but shows you everybody makes mistakes, especially me because I'm silly. Let's undock this, and look how I entered the first two numbers. It's in a matrix. You can't just say 1 1. You have to put it in square brackets. Say 25. There's our polar graph, and let's zoom in to see it spiral. Yeah, there it goes, just spiraling. And it's really rewarding to see. I think we got to the very. Hey, look, that's where it starts. That's pretty cool. Alright, my watch tells me that it is 1 o'clock in the morning. I need to get to bed, and this is the end of the video. You guys have a great Halloween, and I will see you sometime this week. Alright, goodbye.